In this example, we're asked to resolve a force F, which makes an angle of 30 degrees with the horizontal. Hence, we then have to write the force in terms of the unit vectors I and J. Firstly, we're representing this on a diagram. On the axis that has been drawn, horizontally, we have unit vector I, vertically we have unit vector J. You'll see force F has been drawn in. Force F starts at the origin. So it's a straight line going through the origin to some point that we're referring to with coordinates X and Y. We can consider this to be a right-angled triangle. Underneath the axis, I'm going to draw that triangle in. We know the angle between the horizontal and the force is 30 degrees. Because we're dropping a perpendicular line down from the end of the force till we meet the horizontal axis, we know we have a right-angled triangle. So hence, what we're doing is we're finding the distances for the adjacent side and the opposite side because we know that the magnitude of the force is F. Now, back in the days of year 8, year 9, year 10, and so forth, you developed rules for working out the sine of theta, which was the opposite side over the hypotenuse, and the cosine of theta, which was the adjacent side over the hypotenuse. We can use our trig ratios to find expressions for the opposite side and the adjacent side. We know sine theta is equal to the opposite side divided by the hypotenuse. And the hypotenuse, we know, has a magnitude, a length of F. So what we can say is from that, we know that the opposite side is equal to F times sine theta. In this example, we know theta is 30 degrees. Similarly, for the cosine of theta, we can say that the adjacent side divided by hypotenuse equals the cosine of theta. So therefore, we can say that the adjacent side is equal to F cosine 30 degrees. This relationship always holds true and is a shorthand way of working out the horizontal and vertical components for a force. Our diagram, F cos theta is marked in and F sine theta is marked in. So what does this mean? The horizontal component we know is F cos 30 degrees. We know the cosine of 30 degrees is root 3 on 2. So we now have the horizontal component is root 3 on 2F in the I direction, the direction of unit vector I. Similarly, we know the vertical component is going to be F sine 30 degrees. We know the sine of 30 degrees is 1/2, so the vertical component is 1/2 F, and that goes in the direction of the unit vector J. This means that we can express the force as the sum of its two components. So force F is a vector. It's made up of its two components, so force F equals root 3 on 2F in the direction of unit vector I plus 1/2 F in the direction of unit vector j. Please note that we do not write the f and the f with unit vector I and unit vector j as a vector. The direction is taken into account by the two unit vectors I and j.